In this video, we're going to talk about trig equations. And in fact, in chapter 4, we already talked about trig equations. But those were special trig equations. Those were identities. The equations that we're studying in this unit are not identities. So they are not true for all values of x. Or they're not true when both sides are defined. So for example, 2 cos x minus 1 equals 0. That equation is not an identity. There are many values of x which you can sub into the equation, and you'll realize it doesn't make left side equals right side. So our job in this lesson is to solve for values of x which makes left side equals right side, just like any other regular equation. Okay, so the strategies that we use for trig equations will be similar to the equations that you solved in grade 9 through grade 11, but there's just an extra step because, for example, once you isolate for cos x, you need to solve for the angle. And hopefully there'll be special angles. Otherwise, we're going to need our calculator. Okay, let's try the first question here. So solve for root 2 sine theta minus 1 equals 0. And we're told that theta is between 0 and 2 pi. So if you isolate for sine theta, you'll get sine theta equals 1 over root 2. And 1 over root 2 is our friend. That is a very nice ratio because it's going to give us exact values for our angle. Let's see, sine theta is sine is positive in quadrant 1 as well as quadrant 2. So hopefully you remember your special angles here. So it's pi over 4 in quadrant 1 or 3 pi over 4 in quadrant 2. Okay, let's move on to the second question here. So 2 sine squared x minus 1 equals 0. So let's solve for sine squared x first. Sine squared x equals 1 over 2. And then we're going to square root both sides. And this is a common mistake that students make. They say that sine x is equal to 1 over root 2. But sine x is not equal to 1 over root 2. Sine x is equal to plus or minus 1 over root 2. Okay, so it makes a big difference because now I have an expectation of 4 answers as opposed to 2 answers because I'm accepting positive 1 over root 2, which will give me an answer in quadrant 1 and 2. And for negative 1 over root 2, I'm going to get answers in quadrant 3 and 4. So if it's the ratio is 1 over root 2, so x equals pi over 4, or x equals to 3 pi over 4, that's our second quadrant. What about our third quadrant? 5 pi over 4, or x equals 7 pi over 4. Okay, I got quadrant 1, 2, 3, and 4. Now, this is the second common mistake that students make. Okay, they make an assumption that is not true, but they see it so often when they solve trig equations, they just assume it to be true. So what I want you to do, if you made this mistake, so if you write this and you believe these are the correct answers, I want you to go back to example 1 and compare it to example 2. There's a very big difference between question 1 and question 2. So take your time and try to read the 2 questions. So you can pause the video if you want, but the key difference is that with question 1, theta is restricted from values between 0 and 2 pi, inclusive of those endpoints. Okay, so theta could be any value from 0 to 2 pi. But for example 2, we didn't have any restriction on x. In fact, we can say x is any real number. Okay, x can be any angle you want, not just from 0 to 2 pi. So if that's the case, I want you to really use your imagination. Should you really get 4 answers? And the answer is no. You should be able to get an infinite number of answers. So right now we have 4 answers. So how do we get these infinite answers? Because there are many more ways to get a ratio of 1 over root 2. Okay? And there's many more ways to get a ratio of negative 1 over root 2. Instead of just 5 pi over 4 and 7 pi over 4? No, there's many more ways. So how can I convince you that by thinking of trig functions. Okay, so you will get 4 answers if you focus between 0 and 2 pi. But the sine function goes on forever. So that wasn't very pretty, but let's fix that. Okay, the sine function goes on forever. Okay, so just by drawing another cycle, you get another 4 answers. So what is the relationship between, for example, this answer, which is pi over 4, and this answer over here? These two angles here are coterminal. Okay, you're going to get that same ratio with coterminal angles, and that was something you learned in grade 11. So hopefully you didn't forget that. How do you get the coterminal angles? Last year you would have said add or subtract by multiple 360 degrees, but in grade 12 you're going to say add or subtract by multiple of 2 pi, right? You complete full revolutions and you're back at where you started for that unit circle. So there are infinite number of answers here, as long as they are coterminal, okay? And we're going to say k is an integer, okay? You have to tell people what k is, because k is absolutely not a real number. K is an integer. Now, this is actually a very long-winded way of writing the solution. There's actually a pattern. I don't know if you've noticed. Pi over 4, 3 pi over 4, 5 pi over 7 pi over 4. So in fact, you could have said, quite simply, x is equal to pi over 4 plus, let's do k pi over 2, where k is an integer, okay? So if you're having trouble understanding this relationship or how we came about this, change these degrees. This is 45, 135, 225, and 315 degrees. So they're separated by 90 degrees every time, right? 45 plus 90, 135. 135 plus 90, 225. And then 225 plus 90 is 315. And then so forth and so on. So just by adding by pi over 2, you'll reach another solution. Okay, it's okay if you didn't think of this short form way of writing all the solutions. That's okay. The long way is absolutely fine. Okay, let's solve some more trig equations. Okay, so 2 cos squared x minus 1. Sorry, 2 cos squared x minus cos x minus 1 equals 0. Now always check, is there a restriction on x, 0 to 2 pi? So if there is this restriction of 0 to 2 pi, I'm not going to consider the coterminal angles. There are some exceptions which we'll bring up when I will do the 2k pi thing, but in this case I won't. Okay, so some students have a hard time visualizing this, but you have a trinomial here. Now if you can't see the trinomial, let cos x equal y, okay? Or z, or any variable you want. So you're going to get 2y squared minus y minus 1 equals 0. And what do you have? A complex trinomial. So solve this quadratic equation by factoring. So you want to make negative 1. So I put 1 and 1, and I want to make a negative y. So negative 2y plus 1y. Okay, so hopefully you didn't forget all your factoring techniques. So y is equal to negative 1/2, or y equals 1. Do I care what y is? No, we created y. We want to solve for x. So therefore cos x, okay, since y is negative 1/2, then cos x equals negative 1/2, or cos x equals 1. Special angles, negative ratio, so cosine is negative in quadrant 2 as well as in quadrant 3, and we're looking at a reference angle of pi over 3. So 2 pi over 3 or 4 pi over 3. And when is cos x a max of 1? Well, you need to know your graph of your cosine function. So hopefully you get x equals 0 or x equals 2 pi. As with any trig equation that we're going to solve in this lesson, you can always check by subbing it back into the original equation. In fact, I would argue it's a pretty good idea. If you had some spare time on the test, definitely do that. If you're allowed the calculator, then that's pretty fast, but if you're not, it's still worthwhile checking. Okay, so on your spare time, check these 4 answers. See if they satisfy this equation. But I can assure you they do. Okay, so next one. So we have tan 1 minus tan of 2x plus pi over 2 equals 0. So let's do this. So isolate the tan 2x plus pi over 2. Okay. And now, 1. 1 is a very nice ratio when we work with tan because it's a special angle. Now, there are 2 ways to do this. There's the longer way of looking at quadrant 1 and 3, or you can actually just write down one angle because tan has a period of pi because their answers are quadrant 1 and 3 or 2 and 4. So there's a shortcut. So you're going to write 2x plus pi over 2. This angle here, okay? This is the angle. 2x plus pi over 2 is equal to, since the ratio is equal to 1, then it's equal to pi over 4 plus k pi. Now you notice why I had to introduce infinite number of answers here, because there was no restriction. Once I don't see a restriction for my angle, or what are my variable I'm solving for, if I don't see a restriction, I have to really think hard because my expectation is I have an infinite number of solutions, okay? So this pi over 4 plus k pi, if 2x plus pi over 2 is equal to pi over 4 plus k pi, I'm always going to generate a ratio of 1. Now, if you didn't think of this, if you didn't think of adding k pi, you might have thought of this. I'll just write on the side. You might have thought of pi over 4 and any angle coterminal to it, or 5 pi over 4 and any angle coterminal to it. But if you look at pi over 4 and 5 pi over 4, you can reach 5 pi over 4 from pi over 4 by quite simply adding pi, right? So if you know the relationship between tan, you don't have to study quadrant 1 and 3. You can just take the quadrant 1 answer and add by pi, which makes sense because if you remember our first lesson about trig functions and graphing tan has a period of pi. Anyways, with all that said, let's solve for x. So subtract both sides by pi over 2. Oops, that's pi over 4. That's a 4 there. And then divide both sides by 2. Pi over 2, where k is an integer. Okay. So remember, with tan, you can do plus k pi instead of 2k pi. Because tan has a period of pi as opposed to 2 pi for sine and cosine. So I really want you to connect the dots with your graphing of trig functions with solving trig equations. If you know your trig functions and their respective properties very well, solving trig equations becomes easier because you can also even visualize the answers. So for example, when you see cos x equals -½ you should be thinking this graph, the cosine graph, between 0 and 2 pi. Well, this one I put a closed circle here because the restriction up top of 0 to 2 pi. So these answers here, these 4 answers, it's really helpful to know the graph of cos x, and then you'll be able to see the 4 answers. Okay, there should be no more than 4 answers and no less than 4 answers. So your graphing is really helpful when it comes to solving trig equations. Okay, so we're going to start doing some trig equations that are a little harder. Okay, so what do we need to do for these harder trig equations? Well, we're going to need the help of our trig identities. So I really hope you didn't forget those trig identities. So compound angle, double angle, yeah, all your trig identities, Pythagorean identity, all the identities, you need them. Okay, so here 6 cos squared x minus sine x minus 5 equals 0. Unlike example 3, I see cos and sine, because in example 3 I saw cos and cos. Well, I'd rather see cos and cos or sine and sine. I do not want cos and sine. So what's the strategy here? What's the game plan? What's the identity that can help us? The Pythagorean identity. So I'm going to change this to 1 minus sine squared x. And after I write that, I'm very happy because all I see is sine. I can already see the quadratic equation that we're going to build. So let's just do a few steps of simplifying here. So here we got simplify 6 minus 5 is 1, and then I'm going to factor, so I would prefer to multiply everything by -1. And then I'm going to factor. If it wasn't factorable, I'd have to use a quadratic formula, but it does look factorable. So I want to make a 1 here, so plus 3 minus 2. All right, so, oh, by the way, I didn't use the substitution. I didn't let, for example, let sine x equals y. I can see the quadratic equation, and I don't need to do that. But if you have a preference and you want to write let sine x equals y and then factor the quadratic equation, go ahead. Okay, so I personally don't do it, but I'll leave it up to you. And you can see lots of these questions in the homework sheets and in the textbook. So as long as you get the right solutions at the end, I don't really mind. Okay, sine x equals -½ or sine x equals 1/3. So restriction on x is between 0 and 2 pi. So I'm seeing 4 answers. I get 2 answers here and 2 answers here. Quadrant 3, quadrant 4, reference angle is pi over 6. So we're looking at 7 pi over 6 or 11 pi over 6. Ooh, 1/3. 1/3 is not my friend. 1/3 is not my friend because I need a calculator. So make sure your calculator is in radian mode. Okay, and then inverse sine of 1/3. So we got 0.34 about. So that is the quadrant 1 answer. How do you get the quadrant 2 answer? Because sine is positive in quadrant 1 and 2. Pi minus the quadrant 1 answer, the reference angle, will give me the quadrant 2 answer. So about 2.80. If you are having a hard time accepting these two roots, just sub them in and you'll see that approximately left side equals right side. Left side will be very, very close to 0. Now it won't be exactly 0 because we approximated, we rounded. It's about 0.34, it's about 2.8, but you'll get something really close. Okay, if I don't let you use a calculator on the test, I will not be giving you these kinds of ratios because you can't do it without the calculator. All right, let's keep going. So these equations are a little more fun. Let's see. Okay, so 2 cos x plus 3 tan x. So let's play with some identities here. Before I start solving all the examples, so all the questions in example 6, x is from 0 to 2 pi. Okay, so in my head, once I see this restriction, I'm getting a finite number of answers. Okay, I'm not going to do 2k pi or something like that. Okay, so 2 cos x plus 3 tan x. Let's say change it to sine x over cos x, because that's what tan x is. And then, I'm going to multiply both sides by cos x. So I'll get 2 cos squared x plus 3 sine x. Just be careful. Cos x cannot equal to 0. Okay, so I don't want you to lose that restriction in mind. Okay, so cos x can't be 0. You could have also said if cos x can't be 0, x can't be an odd multiple of pi over 2. You could have also written that. Okay, so 2 cos squared x plus 3 sine x. So it's the same problem I had last time. I don't like to see cos and sine. I want to see just sine, for example. So I can do that. 1 minus sine squared x. Okay, I'm going to I'll show all my steps. Factor. So I want to make a 4, a negative 4 in fact. Okay, beautiful. Sine x equals 2. So no roots, which means I can't get any solutions from sine x equals 2. Why not? For multitude of reasons. So you can say what you learn in grade 10 tells you I can't get any roots from sine x equals 2. Because what did you learn in grade 10? Sine is defined as a ratio of the opposite side to the hypotenuse. So opposite of hypotenuse, there's no way you're getting 2. You're telling me the opposite side is twice as long as the hypotenuse? That makes no sense. In grade 11, you learned that the sine, the new definition, sine is defined as the y-coordinate of the unit circle. Well, how are you going to get a y-coordinate of 2? Impossible. What else can you say? Sine x, the graph of sine x, the range is -1 from any value from -1 to 1. So this 2, for so many different reasons, you should realize that sine x equals 2 can't give you anything. Now if those 3 reasons didn't convince you, you could do inverse sine of 2. Okay, your calculator will also convey the same message. Sine x cannot possibly be equal to 2. So no roots. I'm just going to write because sine x bounces from -1 to 1. Okay, so we're not getting anything if the ratio is 2. Alright, so sine x equals -1/2, no problem. I'm going to get 7 pi over 6 or 11 pi over 6. If I can get exact solutions, you definitely have to give me exact solutions. Like, I don't want to know what 7 pi over 6 is approximately. You only give me approximate solutions when necessary. Like in the previous question, I had a ratio of 1/3. Okay, so let's do 6b here. Secant squared x plus 5 tan x minus 3. Okay, secant squared x. You know what? I don't know if you remember all your Pythagorean identities, so I'm going to help you out. So sine squared x plus cos squared x equals 1. Okay, so everybody knows that trig identity. So how can I generate the one that involves secant squared x? Well, secant, what is secant? Secant is 1 over cos squared x. Oh, sorry. Well, secant is 1 over cos, but since I want secant squared, I'm going to divide cos squared x, cos squared x, cos squared x. So that will give me tan squared x plus 1 equals secant squared x. So if you ever forget your other 2 Pythagorean identities, then you can just divide both sides by cos squared x or both sides by sine squared x for your original Pythagorean identity of sine squared x plus cos squared x equals 1. Alright, so I can see my quadratic. So secant squared x is tan squared x plus 1, as I've shown you above. Okay, so tan squared x plus 5 tan, plus 5 tan x plus 4 equals 0. So we have tan x plus 4, tan x plus 1. That's a simple trinomial. So what can we say? Tan x equals -4 or tan x equals -1. -4 is not a friendly ratio, so I need a calculator. -1, that's a friend of mine. That's quadrant 2, 3 pi over 4, or quadrant 4, 7 pi over 4. Okay, so negative 4, not my friend. So what I'm going to do though, I'm going to inverse tan of 4. Okay, now this is a quadrant 1 answer because I took the inverse tan of a positive ratio. But what is the quadrant 1? Is it what is the quadrant 1 answer? It's our reference angle. So using the reference angle, I'm going to find out the two solutions that I will get with a ratio of negative 4. So I know tan is negative in the second quadrant and in the fourth quadrant. So I'm going to do pi minus, so it's 1.82 about. And now do one more time, inverse tan of 4 to get the reference angle. And then 2 pi minus. So about 4.96. So that's it. I got 4 answers because x is between 0 or any value from 0 to 2 pi. If you don't trust 1.82 and 4.96, sub it back in. All right. Let's keep going. We have 3 sine x minus 2 cos x. So this one, it's a little trickier, I'd say. So to stay calm, just play with your techniques, or because you don't have sine squared x or cos squared x, so you don't have a Pythagorean identity here. So what we're going to do is write 3 sine x equals 2 cos x. Now I'm going to divide both sides by cos x. Okay? Be very careful. Okay? Whenever you divide both sides by cos x, you have to think really hard because it's different from dividing both sides by 2, for example. When I divide both sides by 2, I don't blink. Okay, there's no problems with dividing both sides by 2. But when I divide both sides by cos x could be 0. In fact, cos x is equal to 0 for an infinite values of x. Okay, you know that because you know the cosine graph. Okay, so because you can be potentially dividing by 0, you have to be very careful. So in fact, not only will I write cos x cannot be equal to 0, I'm going to write cos x. Oops, sorry. I'm going to write something even more specific. So cos x can't be 0, okay? Because I can't divide both sides by 0. Oh, I made the same mistake. I'm going to write x cannot be equal to an odd multiple of pi over 2, because that's when cos x is equal to 0, at an odd multiple of pi over 2. If you don't know like where I came up with this, go back to the first lesson of the unit and you'll see the cosine graph, and it's equal to 0 at any odd multiple of pi over 2. So it'd be a good idea, very good idea, to see what happens if x were to be an odd multiple of pi over 2. Okay, so this would be 0, so it would be 2 times 0, which is 0, and this would be either, sine x would either be 1 or negative 1, which means it's either 3 equals 0 or negative 3 equals 0 when you let x equals to odd multiple of pi over 2, which is very good news. So these values of x are not solutions to this original equation, which means by dividing both sides by cos x in this case, it's not going to cause any problems. So why did I divide both sides by cosine x? Because look, it's 3 sine over cos tan x. So we go from 2 trig functions to 1 trig function. Bam. Tan x equals 2/3. So x is approximately 2/3 is not my friend. So this one, I'm going to do inverse tan 2/3, so about 0.59. And then we add by pi. Because quadrant 1 and quadrant 3, you can jump to quadrant 3, but the quadrant 3 root by adding by pi, 3.73. Okay, so this is one way of doing this question. Another way of doing 3 sine x minus 2 cos x equals 0 is the first step is going to remain the same. So 3 sine x equals 2 cos x. But in this case, I'm not going to divide both sides by cos x. What I'm going to do is I'm going to square 3 sine x as well as 2 cos x. We'll square the left side and the right side. So if you do that, you get 9 sine squared x and 4 cos squared x. Now you have two choices. You can use the Pythagorean identity to change sine squared x to 1 minus cos squared x, or cos squared x to 1 minus sine squared x. I'll change sine squared x to 1 minus cos squared x. And then you can already see your quadratic. Oops. Okay, so cos x equals plus minus 9 over root 13. So x is equal to, let's see what our calculator says. Oops. Oh, it's not 9. I'm so silly. I forgot the square root. It's 3. I squared the denominator, but not the numerator. Which makes sense. 9 over root 13 is greater than 1. That was crazy for me to take the inverse cosine of 9 over root 13. Anyways, so 0.59. Hey, what do you know? That's exactly the same as my first strategy. But wait a minute. In the second way of doing this question, I'm not going to get 2 answers. I'm going to get 4 answers. Because plus or minus, right? So it's quadrant 1, 2, 3, and 4. There's a quadrant 2, pi minus. Then the quadrant 3 answer. I already know what it is, but I'll do the math anyways. Oops. 3.73. Now, how come I knew it was 3.73? Because I knew the quadrant 3 answer from the first way of doing this question. Quadrant 4, this one I have to do the math, 3 over root 13, and then 2 pi minus, because it's in the 4th quadrant. So we're looking at about 5.7. So, how come I got 4 answers here and 2 answers here? So should there be 2 answers or should there be 4 answers? So the answer is, there should only be 2 answers. So when you do it, when you check your solutions, you'll realize that 2.55 and 5.7, those don't work, okay? So you can try that as an exercise for yourself later, sub them back in, and you realize they are not solutions to the equation. So in the process of solving the equation, we created roots for ourselves, okay? But really, they're fake. They're not real solutions. They don't solve your equation. So what we call these are extraneous roots. Okay, those 2 answers are no good. We cannot accept them because they don't solve our equation. So we should really ask ourselves, where did we introduce these extraneous roots? And the answer is right here. When we squared the left side and the right side, we introduced 2 roots to the equation, which aren't really roots. Okay, if the question began as 9 squared x equals cos squared x, beautiful. These are absolutely acceptable. But that wasn't the question to begin with. The question to begin with was 3 sine x minus 2 cos x. Okay, so when you square both sides, you have to be very careful because you may be introducing solutions which aren't really solutions. So it's always a good idea to check your solutions. Because they may be extraneous roots. Okay, so and that goes for when you square both sides. That's especially true because squaring both sides not always, it may create more solutions for yourself, which in fact are not correct. But when you divide both sides by 2 or like multiply both sides by 12, then you don't worry as much. But when you square both sides, that's a little dicey. Okay, so enough with C. Let's do D. cos 2x plus sine x. Once I see cos 2x, I'm thinking double angle formula for cosine. Which version should I use? Well, hopefully you remember all three versions. You have the cos squared x minus sine squared x, 2 cos squared x minus 1, and 1 minus 2 sine squared x. The version that's most useful in this case is 1 minus 2 sine squared x. Because I create my quadratic equation, right? Clean it up, and then multiply both sides by -1 so I can prepare it nicely to be factored. So I want -1, so -2 plus 1, -1. Oops, that's +1. Okay, beautiful. I love these ratios. No need for calculators. -1/2, so we're looking at 7 pi over 6 or 11 pi over 6. Quadrant 3 or quadrant 4, reference angle pi over 6. X equals 1, I know the sine graph. It's only a maximum at pi over 2. Beautiful. I can't say this enough. The graph really helps. Okay, so that's that. One more sheet to go. A side note, trig equations are very useful when it comes to word problems. You have to be able to solve trig equations, otherwise you won't be able to solve the word problem. Okay, so I see a double angle formula. So sine 2x, 2 sine x cos x, 1 minus, I just missed something. I'll tell you what I missed in a second, but you might not see that. So 1 minus cos 2x. So I'm going to use the double angle formula of the 1 minus 2 sine squared x equals -1. So 2 sine x cos x, simplify the denominator. So you get 2 sine squared x equals -1. So you get cos x over sine x. And that's cotan x. Cotan x. Tan x equals -1. So what I missed was the double angle formula for cotan. Yep, because this is it's not double angle, half angle formula. This is the half angle formula for cotan. So from here, I could have just wrote cotan x equals -1. I didn't need to do all the simplifying. I missed that boat. Not a problem. Do what I did and you'll still achieve the same thing. But I really wish, but once I started writing the double angle formulas, I was like, yeah, I'll just keep going. But this is the half angle formula for cotan. So if you didn't see that, like I missed it, then just write down what I wrote. So once you get cotan x equals -1, take the reciprocal of both sides. But if you're comfortable with solving for the angle from cotan x, go right ahead. Don't change it to tan. But I would argue most students prefer working with sine, cos, or tan. Okay, when is tan negative? Quadrant 2 and quadrant 4. So we're looking at a ratio 1, so it's reference angle of pi over 4. All right. Nice. 4 sine x cos x minus 1. So when I see sine x cos x, I always I see double angle formula. I see the double angle formula for sine. And I can't say this enough, if you didn't memorize your identities for chapter 4, redeem yourself and memorize it in chapter 5. It goes a long way. It really helps you solve trig equations, especially the more complicated ones. So this is 2 sine 2x minus 1 equals 0. So sine 2x equals half. Now I'm going to pause for a second, and I really want you to take a look at what I wrote here. Sine 2x equals half. How many answers do you expect to get from this equation? If x is between, or x is from any value 0 to 2 pi, okay, you can only accept the solutions when x is from 0 to 2 pi, then how many answers should you get? So a lot of you are probably going to say 2, and hopefully I can convince you otherwise, because a lot of students are just going to give me two answers here. But after you write two answers, I want you to, really think about it and say that is not correct, because it's sine 2x. Basically, I'm going to graph y equals sine 2x, and look, there are two cycles. From 0 to 2 pi, that's two cycles. So how many answers should I get? The answer is 4. That's half there. I should get 4 solutions. Okay, so the question is, how do I get my 4 solutions? So this is where the coterminal angle thing happens. 2x, the angle, is equal to, so if it's the first quadrant, we're looking at pi over 6, or 2x equals quadrant 2, 5 pi over 6. But you see, if you divide both sides by 2, you'll get your two answers. Right? You get two answers. I don't want two answers. I know there are 4 answers. Okay? So what you should have said instead is pi over 6, or any 2x could be pi over 6, absolutely, or any angle coterminal to pi over 6. Any angle coterminal to 5 pi over 6. And of course, k is an integer, and then you'll get beautiful k pi. I really like that k pi. Why? Because the period, if it's y equals sine 2x, the period is pi, not 2 pi. So I expect that. Now, this is beautiful. I have infinite solutions here. Okay, I have gathered all the answers that can solve this equation. Okay, but since x is restricted from 0 to 2 pi, then x equals pi over 12. Okay, now I have all the answers, I have infinite solutions, but because of this restrictions, I can only take 4 of the infinite answers. So how do I get the other 2 answers? You add by pi. Okay, 13 pi over 12 and 17 pi over 12. Let's try again here. Can you adding by pi? Yes, but it's not a good idea, because once you add by pi again, for example, 13 pi over 12 plus pi would be 25 pi over 12, which is just greater than 2 pi. Okay, so since this is a restriction, you can only accept these 4 answers of the infinite answers you have. So a lot of students always ask me, okay, you did coterminal here, the 2k pi and 2k pi, but why didn't I do it here? Like, when should I do 2k pi, when should I not do 2k pi? So here's my advice. If you always do it, it won't get you the wrong answer. Okay, it's just more work, but you'll never get the wrong answer. Okay, by finding all the answers to the equation and then rejecting all of them, all the ones except for the ones that fall within the restricted domain, that's never a bad idea. Okay, that's always going to be getting you all the correct solutions for the equation. Okay, but if you want to save time, when will I be showing you this 2k pi? When I see that it's not just sine x. If it's sine 2x, sine 3x, sine half x, I'm basically changing the period of the function. So the number of solutions can change. It's no longer going to be 2. So since I can change that, then I really want to obtain all my solutions and then reject all the ones that don't fall in that interval. So if I don't see a 1 here, a coefficient of 1, I am doing the 2k pi. I'm looking at the coterminal angles. Another reason why I'll do 2k pi is if the restriction is not from 0 to 2 pi. If it was some weird restriction, which you see some of the textbook questions, if it was like -3 pi over 2 to 0, I'm definitely doing this, I'm going to study the coterminal angles and extract all the solutions to the equation, okay? Because once the restriction is different, then I want to make sure I actually have all the roots. Yeah, so it's never a bad idea, but there are certain times where I do try to find all the roots for you. Another reason is if there are no restrictions. If they didn't give me this restriction, if x wasn't restricted from 0 to 2 pi, I'm definitely studying all the coterminal angles. Okay, because that's the only way I'm going to achieve all the roots to the equation, by studying the coterminal angles. Okay, for the last example here, I'm trying to find the point intersection between f of x and g of x. So let's set f of x to be equal to g of x here. So 2 cos squared x equals 5 sine x minus 1. And then 2, so cos squared x, use a Pythagorean identity, 1 minus sine squared x. 2 minus 2 sine squared x, 5 sine x minus 1. So 2 sine squared x plus 5 sine x minus 1. Factor. Something's off. Minus 3. Because it wasn't factorable. Anyways, 2 sine squared x, so 2 sine x. Let's make that 3 a little prettier here. Plus 3 to get the 6. 6 minus 1, 5. It's just a complex trinomial, really. So, sine x is equal to half, or sine x equals to negative 3. So x equals to pi over 6, quadrant 1, or quadrant 2, reference angle pi over 6. Now, sine x equals negative 3, that's crazy. No roots. Because sine x can only be equal to values from negative 1 to 1. Okay, that's the range of sine x. Alright, what else? Oh, we have to solve for the point intersection. So f of pi over 6. 2 cos squared pi over 6. So this is 2 root 3 over 2 squared, which is 3 over 2. F of 5 pi over 6 is equal to 2 cos squared 5 pi over 6, which is equal to 2 negative root 3 over 2 squared, but still 3 over 2. Okay, therefore, the point of intersection between f of x and g of x are, let's see, pi over 6, 3 over 2, and 5 pi over 6, 3 over 2. Okay. So this lesson, we're just solving a bunch of trig equations. Some of them you need some identities. You need to know your special angles because I will be asking for exact answers. You also need to use your be able to use your calculator and find the approximate answers if necessary. Really know your identities and be prepared, because some questions I will not restrict x to be from 0 to 2 pi. I'm just going to let x be anything in any real number. So if that's the case, you need to be able to study coterminal angles and extract infinite solutions. So this lesson is quite a bit, but I have two really good homework sheets. One of them is a challenge sheet and it really tests your ability to solve trig equations.